Hello, everybody, and welcome to this first session on security testing here at ESEM 2021. My name is Davide Fucci from Blekinge Institute of Technology in Sweden, and we have today four talks, three from the technical track and one from the emerging results and vision paper track. Let me bring on stage our first speaker, Nasif, who's gonna tell us about a comparative study of vulnerability reporting by software composition analysis tool. Sim.
Yeah, hello everyone. Welcome to my talk
Sim,
on.
just before you start, we can see your presenter screen instead.
Okay. Yeah, I think yeah. Hello everyone. Welcome to my talk on software composition analysis tools. I'm Nasif from NC State University. To dive straight into the topic, what is an SCA tool? SCA tools report the known vulnerabilities in the open source packages that you use in your project. Note that these tools also do license checking and automatic updates, among other things. But the scope of this study is only the vulnerability reporting aspect of SCA tools. So why do we need a comparison study? Simply because many tools exist in the market and we want to systematically study if they report the same thing, and if they do not, then what are the differences? So we investigate two research questions in this study. First, we investigate the difference in vulnerability reporting of the study tools. And then we also categorize what metrics are provided by the tools that we study to help in risk assessment of these dependency vulnerabilities. So before I talk about the name of the list of the tools that we study, I want to mentioned that the evaluation subject is we chose a web application, OpenMRS. It's a Java and JavaScript based web application and has a large number of dependency. And for clarification, by dependency, we mean each unique package and version. For example, Lodash 1.4.1 would be a dependency of OpenMRS project. And on that, from that point, we scoped our study only to tools that only scan Java and JavaScript projects. And so while selecting SCA tools, we noticed that they can differ in three dimensions: what vulnerability database they use to report the known vulnerabilities in your data dependencies, how they scan the dependencies, and any additional analysis for risk assessment. So while we select the popular and available tools, we also made sure that they differed on at least one of these dimensions from the other tools. So we have a comprehensive comparison. So finally, we selected 9 tools. 8 of these tools scan Maven projects, and 5 of them scan NPM projects. And as you can see, some commercial tools were bound by the terms of use to not reveal their names. So let's look at our findings. The research question 1 is basically what are the differences between the vulnerability reports produced by the different SCA tools. And there is a lot of numbers in this slide, and I will not bore you with all the details. But as an overview, we found tools reports to vary on a wide range, and that is both in the terms of which dependencies they report as vulnerable and what are the specific vulnerabilities. And regarding vulnerabilities, we also find that tools report CVEs, which is common vulnerability enumeration, the most well-known vulnerability identified, but they also reported vulnerabilities without a CVE. And you can see that WAS dependency check has a large number of alerts or vulnerabilities and dependencies, but that may be an inflated count, and I'll shortly discuss why is that when I discuss why did the tools differ. But you can see that the range is quite wide, and some tools just some tools are there in the middle. And to understand the non-overlap in the reporting. So this is a Venn diagram of 3 representative tools, and I want to note, like, in this diagram here, I chose the 3 tools that were like closest to each other in their reporting, and you still could see the non-overlap both in the dependencies they reported and the CVs, and you could see even with the tools that were close to each other that there are non-overlap in the reporting, which basically shows that how the tools differed from each other. So we manually analyzed the reports to identify what are the differences, why are the differences, because all the tools are supposed to report the known vulnerabilities in your dependencies. So why did the differences occurred? And we identified 8 reasons in our paper, and I will not touch all of them, but I will touch the important ones. So first, we found that Maven projects could have JavaScript files such as jQuery handlebars, and these dependencies are not necessarily declared in the manifest files like POM XML for Maven, and most tools except 2 fail to report them. And then we also saw the metadata of the vulnerability can be inaccurate. For example, what versions are actually affected by a vulnerability, and tools may simply give a false report of a version as vulnerable, while the vulnerability actually affects some different version. And for DC, we found that simply relying on NVD data can lead to inaccuracies as well, because many packages share the common product identifier, CP identifier, for which we saw that OSDC repeated the same vulnerability across like multiple packages and inflated the total dependency count. Finally, one other important point is that CVs from National Vulnerability Database are typically incorporated by all the tools. But besides this, we found that many vulnerabilities may get reported on one tool's database and not in any other tools. For example, the Sneak and GitHub, all of them have their own advisory database. And this can result in unique non-CVs. All the tools that reported non-CVs in our study, so 6 tools out of 9 reported at least one non-CV, and all of them, we found that they had at least one non-CV not reported by any other tools. So as key takeaways from the findings of RQ1, we find that for an SCA tool, a key strength point is its vulnerability database need to be accurate and up to date. And we also found that many vulnerabilities may get reported to only certain databases, and that implies some vulnerabilities may not get reported at all, which creates the risk that there still may be some known vulnerabilities in the packages or dependencies you use that are not reported by the exact SCA tool you are using. Finally, while modern package managers use some manifest files where they declare all dependencies, I think the project developer and maintainers need to be careful of any open source dependencies outside such manifest or dependency files, because we saw that most SCA tools do not pick them. Our second research question was what metrics are presented by the SCA tools to help you in assessing the risk of dependency vulnerabilities, because a common complaint with using SCA tool is that I have this, like, say 100 dependencies, direct and transitive, and some vulnerabilities in the transitive dependencies. That library I may not use at all, so that does not affect my own application. So we wanted to see like what metrics or how the tools help on this regard. And as I say, we categorize the metrics in 5 high-level category, but due to time constraints, I'll not go into detail. But if I were to highlight one thing, I would say the code analysis-based metrics. So 2 tools in our study perform static and dynamic analysis to determine if the vulnerability in the dependency actually reachable from your code or not, to signal if your application is affected by it. But overall, we found different tools to do different things, provide different metrics, which highlights, in our opinion, the research need for a common risk measurement framework specifically for dependency vulnerabilities, and evaluate if that metrics is good or not, and the developers accepting those metrics or not, and so that can be adapted commonly by all the SCA tools. So To conclude, I already discussed about how SCA tools should have an accurate, complete, and up-to-date vulnerability database. That probably one of the uh, key points about SCA tools. But we also recommend practitioners, maybe this may be a hard recommendation, but maybe not rely on any single tool at the present, because that can result in like missing missing report of known vulnerabilities, or getting notifications with a delay. A vulnerability may be discovered in October, in you getting a notification in December. uh, and mm, after, future research should look at like how we can build automation technologies for continuous monitoring of such vulnerability data, so that we don't rely on any specific third-party databases, third-party tools. And we also should establish frameworks and metrics to identify false positives, and assess risk for dependency vulnerabilities. So that was all for today. Thank you for listening to my talk. I'll be happy to take any questions.
Thank you so much, Nasif, for your talk. While maybe the crowd warms up, I have more like a curiosity
Yeah.
about the SUT that you use. So you use a single SUT, which I guess it's fine, but can you maybe tell us a little bit about the effort uh, behind, collecting data, and maybe how much manual step that involved? And
Yeah, so I guess by SUT you means the single evaluation subject, the OpenMRS that we
yeah,
tested the tools on.
yeah,
Yeah, yeah. So the effort that went on, out of the 9 tools, probably most of the tools had little effort. Like for example, Sneak or OSDC, they had very straightforward instruction on how to run on the project source code, on the manifest files, and they'll give you the reports. But few tools, for example, and those are probably most commercial tools, which say scan the binaries or did the static and dynamic analysis. Those required a more sophisticated setup. For example, for performing the static and dynamic analysis, I had to run all the integration testing so that the tool can have the execution traces for dynamic analysis. So those are basically needed more expensive or heavy setup, and which was one reason that we focused on one web application that met all the criteria of these 9 tools, and could not scale it for a lot of projects. And when I get the data, so each tool provides data in different formats, and then I have to kind of manually have to parse and pre-process the data, so that I can compare across the tools.
I see. Well, since you touch upon commercial tool, do you have any maybe insights on or deeper insights on the differences between the performance of those three commercial tools, I guess, versus the other 5?
So I would say, for example, the static and dynamic analysis for risk assessment, one commercial tool does that, and also the Steady, Eclipse Steady open source, which is more of a research tool, they do that. So there are commonalities in that. I think one aspect that stands out, one of the commercial tools, uh, what I would not say much details, because that could basically reveal what the tool is, and but they kind of tracks your application during runtime to see like which, if you're actually using the libraries or packages or not, so that they can tell you that these ones are really high priority, and maybe the other vulnerabilities are not a high priority for application. But yeah, I would not go into more details by that
Okay,
would reveal the names. Yeah.
I understand. There is one question. Uh, Abdularias is asking, how can we find the integrity of data?
So we have made the code and data both available. I think the link is not in the paper. I apologize for that, but the media is attached in the ESEM website. So the data is available, but the link of the data is not in the main paper body. So I apologize for that.
Okay. Thank you very much,
Yeah.
Nasif. That concludes this first presentation. And so let's move on to the second paper from the technical track. It's an empirical study of rule-based and learning-based approaches for static application security testing. Our presenter is going to be Roland Croft from University of Adelaide. And I'm going to bring Roland on stage. Here you are, Roland. Welcome. Please.
Hey. Yeah, all good. So yeah, I'm Roland. I'm a PhD student at CREST, which is a research group for the University of Adelaide. And I'll be presenting my research, which I think follows on quite nicely from Nasif, because I'll be presenting insights into a different security tool, static application security testing. So let's get into it. Now, organizations are on a quest to secure their software, but with systems getting larger, it's both difficult and time-consuming to identify which parts are vulnerable. It's estimated that 1 hour of secure code review can only cover 500 lines of code. So there's a lot of interest in automated methods for vulnerability detection. Particularly static application security testing, or SAST, is an attractive approach for ensuring software quality assurance early in the life cycle. In a recent study of open source development practices, it was found that over half of the repositories used these static code analysis tools. Now, conventional tools use rule-based methods which leverage knowledge from security experts. In this example, the tool can use its knowledge of buffer overflow vulnerabilities to create a check for out-of-bounds buffer assignment. Whilst this is effective to a degree, it's not perfect. These checks are often quite simplistic, which means there's a lot of false positives, or they fail for more complicated checks. As a result, these conventional tools often fail to make inroads into software development practices. From that same study of open source development, 64% of those repositories which use the static analysis tools only use them sporadically or didn't actually attach any consequences to their outputs. Now, with the rise of AI, many difficult tasks are being automated with learning-based methods, and with the challenges for SAST, it's no such exception. Essentially, we can use historical examples of vulnerabilities to automatically learn these patterns and predict new ones. Essentially, we're learning from our past mistakes. Now, these AI solutions are becoming very popular in literature and in industry as well, with the growing abundance of open source vulnerability data and the continual advancement in AI technology. For example, Snyk, one of the top security vendors, has recently adopted an AI engine for their static analysis tool. So really, we've observed two main approaches for static application security testing: the rule-based methods, which use these predefined patterns, and the learning-based methods, which use the automatically learned patterns. However, up till now, they've really existed in isolation. We've lacked that comparison into their capabilities, and we aim to bridge this gap with our study. We look into their relative strengths and capabilities, and really we want to see to what extent SAST is achievable. Ultimately, like, what method should we look towards in the future? So to conduct this study, we've done a large-scale empirical analysis by applying a suite of these tools and models to large code bases and vulnerable examples. We've collected the code bases of the Linux kernel, OpenSSL, and Wireshark from GitHub, and vulnerable examples in these code bases from the National Vulnerability Database. To provide an additional view, we've also considered a vulnerability benchmarking dataset from the Juliet test suite. Unlike the other ones, this contains synthetic vulnerability examples and code, which is specifically designed to test the capabilities of these tools. In terms of our method that we've evaluated, we tried to collect a set of representative examples of both approaches. For the rule-based methods, we have SAST tools, and we looked into tools which were open source and widely used in the community and by large organizations. These are CPP check, Forfinder, and RATS. For the SVP models, we picked representative models that were commonly used as baselines in the literature. These are models that make predictions from software metrics or directly from code tokens. Now, in terms of what we've evaluated, for our first research question, we looked into actually the most important capability of any SaaS solution, their ability to actually detect vulnerabilities. We measure this through each approach's ability to provide a warning for a file that contains documented vulnerabilities in our dataset. For the second research question, we consider a secondary task of vulnerability mitigation, which is vulnerability assessment, the ability for each approach to provide us extra information with the vulnerabilities that they've detected. And we evaluate this through their ability to classify the type of vulnerability. Finally, for the third research question, rather than pitting these methods against each other, we see whether they can synergize together in a combined approach, whether it would actually be more beneficial to consider them both together rather than in isolation. Now, we evaluate these research questions by measuring the recall, precision, and MCC of each approach under each circumstance. The recall measures the ability to actually spot all potential vulnerabilities, whereas the precision measures the actual correctness of their outputs, and the MCC is a more balanced metric, which measures the overall performance. Now, let's briefly move on to our findings. Of course, for time, I won't be able to get into everything, but I'll try and highlight some of the main ones. So for the first research question, we look at the detection performance. And our first observation is that for the recall, it's not actually that different between these two approaches. They predict a very similar number of vulnerabilities. And when we looked into the files that they're actually providing warnings for, we found quite a significant overlap. So they're actually able to detect quite similar things. However, for the precision, this is where we see the main difference, as the learning-based approaches, the SVP models, have a much higher performance. This is because the rule-based methods are actually producing a much larger number of outputs. They tend to err on the side of caution, so they'll overclassify things as vulnerable, and this produces much more inaccurate warnings as well. Now, for our second research question, we again compare them except for their ability to classify the type of vulnerability. Again, we see the learning-based methods are much more accurate. However, for this one, both approaches actually perform worse than they did in the previous detection task. This is because both approaches are constrained quite heavily in the types that they can predict. For the rule-based methods, the SaaS tools, they're very constrained because they can only predict the types that they actually built and target towards, the ones that they've explicitly incorporated checks for. And for the SVP models, they're only able to accurately predict the types for which there's adequate training data. The more obscure vulnerabilities, they struggle to learn the appropriate patterns. Now, this constraint appears to affect the SaaS tools more heavily through the performance, as often these tools are targeted towards quite a few types of vulnerabilities. Now, finally, we move to our last research question about unification, and we look into two approaches for this. We explore two different ways. For the first one, we consider a naive approach in which we just take both tools and we run them in parallel, and then we merge their outputs. Now, this creates a much larger number of outputs if we just run one tool, so naturally the recall does increase, but we find this to be a bad solution as the overall performance really decreases due to the much larger number of outputs. For the second approach, we aim to see whether the knowledge produced from the SaaS tools can actually be incorporated and learned from by the prediction model. In this figure 4, it shows the performance of each of our SVP models, and the orange bars indicate the performance increase from adding this extra knowledge from the SaaS tool. Now, the bars to focus on are the ones on the right here, as this is our best performing SVP model. And we can see in one of the 4 data sets, do we actually see any kind of improvement? So again, we're failing to really produce something that's greater than the sum of its parts. That's better than if we just use the SVP model on its own. So really for this last research question, we essentially failed to identify synergies between them, which leads us to our conclusion. So we've identified the relative capabilities for each, and we provide suggestions for which ones to use. Ultimately, they both produce similar capabilities in terms of recall, but the SVP models exhibit several enhancements in terms of the performance for precision and the assessment capabilities. However, we noticed that they also have some additional caveats. The SVP models need training data and tuning, and offer coarse granularity and interpretability. So we see a lot of promise for these learning-based methods, but we still think there's a lot of barriers for adoption, which we look forward to being investigated in the future. Thank you.
Thank you very much, Roland, for the nice talk. Also, considering the time in Australia right now.
Yeah, it's quite late here.
Let me see if it's any question for you in the chat. Well, while the crowd warms up, there is a question from Federica. She's asking, have you considered Imtiaz et al. The importance of accounting for real-world labeling when predicting software vulnerabilities, published at FSC 2019?
Yeah, I am familiar with that paper. Just as a follow-up, was there anything in particular that you were referring to? In terms of the evaluation setup, we didn't consider a time-based evaluation like is recommended in that paper, as we failed to do this for our methods. We instead used bootstrapping, which was recommended in another work for defect prediction. But yeah, if you had a follow-up specific, I'd be happy to answer that.
Maybe while Federica types in a question, I have more like a curiosity or maybe a detail I missed. So the classifier that you built for the SVP models, are they hierarchical classifier to take into account the first and the second research question, or you built two different classifiers for each of them?
Yeah, that's a good question. We did build two different classifiers. So for the first one, it's a binary classifier, which just predicts the presence of a vulnerability, yes or no. And for the second one, it's a multi-class classifier, which predicts the type.
Okay, great. And yeah, there's the answer from Federica is yes. I was asking about the data validation process.
Okay, I hope I answered that then. But there's of course more details in the paper if you're interested.
Maybe finally also a quick question from me regarding the integration or failed integration between the two approaches. So the second approach that you had, where you use the SAST as an input for the SVP. Can you say a little bit about more which kind of features did you get from the SAST?
Yeah, so we collected a range of things, which again, I'd have to refer you to the actual paper to see all the details, but essentially it's things like, do they provide a warning, which tools provide the warning, the messages that they provide the warning for, where they provide the warning, the tokens they're highlighting, that kind of thing.
Gotcha. All right. Thank you so much, Roland, for the presentation and for answering our question.
Yeah, thank you.
It's now time for our third speaker, also from the technical track. And the paper title is An Empirical Analysis of Practitioners' Perspective on Security Tool Integration into DevOps. And we have Roshan here. Hello, Roshan.
Hi.
Hi, feel free to bring up your screen.
Yes. There's a permission issue. 1 second, please.
Yeah. Great.
Can you see the screen?
I can now add the screen. I can see the presenter view.
Oh, okay. I will share the displays.
Yeah, great. I think you're good to go. Please take it away.
Yep. Hi, everyone. So, sorry for the delay. So I'll start by giving a brief. So my talk is on empirical analysis on practitioners' perspectives on security tool integration into DevOps, and I think my talk also flows smoothly from the first two speakers. But our work is on from the qualitative perspective and a specific focus into the DevOps paradigm. So my name is Roshan. So I'm a PhD student at the Center for Research on Engineering and Software Technologies, CREST, at the University of Adelaide, Australia. So I start by giving a brief introduction into my domain, the DevOps paradigm. So with the business environment getting more and more competitive, so the organizations are now requiring software development teams to develop products faster and to react to changes more quickly. And this is where the DevOps paradigm came into the picture. And so the main recommendation of this paradigm is to remove the traditional boundaries between the software development team and the operations team. So the main result intended was to
I think we're having some problem with Roshan connection. Okay, Roshan, since you're back, you're muted. Roshan, you have to unmute yourself, and you need to reshare your screen.
Yeah, I need to reshare, right?
There you go. Okay,
yeah.
we can.
Sorry, permission issue with my Mac.
No
So you might have seen this infinity loop, so which symbolizes the main message in DevOps. So this actually captured the paradigm shift and the continuous and iterative nature of DevOps. So now I'll explain the main problem that I'm addressing in my research, the problem domain. So while in DevOps, the increased speed of deploy, with it enabled increased speed, practitioners are now facing the challenge of developing secure software while maintaining the speed, presented by DevOps. So in DevOps, we have this tool pipeline where the software or the code can be delivered smoothly and quickly and continuously, more importantly, from the developer's environment to the operations environment. So this pipeline is one of the fundamental principles of DevOps, which enables continuous deployment. So one of the main challenges that practitioners are facing with this paradigm is to integrate security tools into this pipeline smoothly. So this is actually the problem area that we are trying to address, and the focus here is application security tools. So as the first two presenters also touched on, so these tools are very useful in terms of detecting security vulnerabilities. But the problem is that when these tools are integrated into this DevOps pipeline, many studies and many practitioners report that there are many drawbacks that affect DevOps goals, like the deployment frequencies. So the aim of our study is to empirically investigate how these tools can be integrated into a DevOps workflow without affecting its rapid delivery goals. So now I'll explain the method that we have used in our study. So in our study, we report a novel use of webinars as a data source, and which is a data source rich with practice-based information. So our previous studies in this domain, we had a literature review done recently, and it made us evident that the content published in the papers in this area are a few years behind compared with what is actually available in the industry. And also, as an emerging area, we found that there was a limited amount of academic research papers available. So then we actually try to look at how we can systematically synthesize practitioner recommendations so as to fill in these gaps. And this is where we actually encountered Devops TV, which is a YouTube channel which hosts a lot of DevOps related material. And these webinars are conducted by actually experienced DevOps practitioners and tool producers, and therefore they are very rich with practice-based and updated information. So we found this resource very useful. Just to briefly explain the analysis method that we used. We actually selected 3 playlists which actually had the most recent webinars. So that's 2017 to 2020, and we had 426 webinars selected in the first stage. And then what we did was we then used the title to filter out the webinars, where we then filtered videos with only a security focus. So we used the title, then we selected 95 webinars from that. So this is DevOps and security. And in the next stage, we then used the description of that webinar to select the webinars which has a specific tool focus. So in our study, we selected 31 webinars, and this would be in the intersection of DevOps, security, and security tools. So after this selection of these 31 webinars, we then obtained the transcription using a Python API. And then we then imported these transcriptions to NVivo, a thematic analysis software, a qualitative data analysis software, and we then did thematic analysis. So the purpose, our intention here was to devise the key challenges of integrating security tools into DevOps, and then to find the current and emerging security tools which the practitioners discussed, and the key recommendations that they proposed in terms of integrating these security tools in a DevOps pipeline. Just to briefly explain some of the key findings due to time limitation, I'll just touch on the main themes and what that theme actually captured. So in terms of the first theme, practitioners believe that the existing security tools had outdated underlying technologies, making it difficult to cater for modern software development methods, and particularly new software delivery tools like CI/CD tools. For example, they discussed how the scan and perimeter-based security model of the existing established tools are not suited for DevOps. And in the next 2 themes, they discuss the limitations related to functionality, and then limitations related to output, such as false positives. And as the final theme, they discussed that these tools are very difficult to integrate with other security tools, and then the most important tool pipeline in DevOps. And as a reason for this situation, practitioners pointed to the fact that many of the current established security tools are disparate, static, and disconnected. So I will then briefly touch on some of the synthesized recommendations that we encountered. So in terms of the tools, practitioners were now focusing, pushing users, pushing developers towards the emerging security testing tools. And these were some of the technologies that we encountered in our analysis. So for example, some of the most discussed type of tools were these hybrid tools where, for example, interactive application security testing, which actually combines the benefits of static analysis and dynamic analysis tools, and then runtime application self-protection tools that use runtime instrumentation to detect and block attacks. And we then also synthesized a set of security practices related to vulnerability scanning, triage, and remediation, and these are all described in the paper. And finally, we integrated these recommendations into a DevOps workflow. So in the left, you see a typical DevOps workflow, and in the middle, in purple, we see the tools that were mostly discussed in the webinars and the integration points as recommended by practitioners. And we then connected, these tools with the pipeline with some of the selected processes which were discussed in the DevOps workflow. So we think that this could act as a template, and we're actually using this as a baseline, as a starting point for further evaluation in our next studies. To conclude, so we reported that there is a gap in the technological innovations between existing security testing tools and software delivery technologies which enable DevOps. However, emerging security tools are addressing some of the requirements of DevOps, but we conclude that there are many tool-related drawbacks yet to be adequately addressed. Thank you. I'm happy to take any questions.
Thank you so much, Roshan. Also, thank you for staying up late to discuss this interesting work with us. I believe it's very interesting to see the data source you used. Connecting very well to what the keynote speaker mentioned. Data sources is not just code anymore; it's even webinars.
Yeah.
I actually have a comment or a question that comes from my own experience working with practitioners. And when you talk about the problems that they may face, they usually bring up something related to auditing or something related to policy compliance in their pipeline. But I think I didn't see this topic in your result. Was this? Do you have any insights on this?
So I think if you take the bigger resource, Devops TV, and if you have a look at their own, the content that's published there, there are actually webinars specifically discussing this aspect, which is, you are correct. But in our study, in our filtering stage, we actually had a specific inclusion and exclusion criteria. So we wanted to specifically look at tool integration and tool usage, that angle. And so in the filtering stage, we actually filtered out that angle. So we had a specific focus in this study. But you're correct. That angle is actually one that is of interest for practitioners.
Okay. Thank you very much. I don't see any questions in the chat, and we are running out of time. So I'd like to thank you once more, Roshan, and I'll move on to the next speaker. So we have, last but not least, a paper from the Emerging Results and Vision track. So let me bring up Saman, who's gonna tell us about why some bug bounty vulnerability reports are invalid. And Saman, please share your screen so I can also bring that up on stage.
Sure. Let me just share. I have some technical issue sharing.
Oh.
David, would you able to, if I send the link,
Mm-hmm.
Are you able to share it?
Probably I could.
Okay, let me try. Sorry. I would be able to just finalize it in 1 minute if you guys let me. Sorry.
Just a reminder for the audience, this is a shorter presentation of 7 minutes. Yes, I think we're there. Perfect. Okay, Saman.
Okay. Really sorry for the
No
delay.
problem. Please.
Sure. Hi, everyone. Good afternoon. My name is Saman. I'm from University of New South Wales, Sydney. The topic of my work, our work is why some bug bounty vulnerability reports are invalid. But I would like, before going to explaining the work, I would like to just highlight some kind of like a concept in this domain. And the first one is the main one is, what is bug bounty platform? The bug bounty platform, a crowdsourcing web-based application that aims to reduce the company risk of security vulnerability by leveraging a large community of the security researchers, which we also call security pros. Companies can use these platforms to create bug bounty programs and offer a reward to individual sec pros who submit a valid report. Some of the example of these bug bounty platform are HackerOne or Bug Bounty, BugCrowd. And the companies that currently using this platform are, for example, Twitter, Slack, Airbnb, Uber, and then there's a big list of companies that currently they're using these platforms. The components of these platforms, it consists of 4 main components. If you want to look at from very high level, the security professionals that they have create a profile, they submit a report, they could view other public reports, and they can see the programs and their policy pages. The second one is the vulnerability reports, which is just a proof of concept of a vulnerability weakness. Then the companies that they use these platforms to create their programs, they create their policy pages, they receive a report from the security professionals, they review the reports, and they give a reward if the report is valid. And then finally is the policy page, which basically is a task description. So programs describe what is in the scope of their program, what they consider as a vulnerability. So then security professionals, they can look at these policy pages, and then based on that, they can find the vulnerability and report it to the programs. This is an example of a policy page from a Twitter. So basically they are explaining what they consider as in the scope and what consider as out of the scope of their programs. And this is an example of a report that was submitted by this security professionals, and then the content of the report, and then the report, the comment from the reviewer, which in this case, they're rejecting this report as kind of like not applicable. Problem and the research gap. The main problem in using this platform was about the invalid reports. It is a serious concern for both organizations as well as SEC professionals. For organizations, this is concern because they receive a huge amount of invalid reports and they need to mitigate it or triage these reports. And for security professionals, it is a very concerning thing because they don't want to lose their reputation, because many programs, they apply penalty on the security professionals that they submit invalid reports. A little empirical study conducted to identify really the nature of invalid vulnerability reports. HackerOne currently techniques to mitigate invalid reports are mainly user reputation and signal limit based, which basically they're looking at the users and they ask user to have a certain amount of reputation or to be able to submit a report to the programs. So this reaches us to our main research question: what are the reasons that make some vulnerability reports to mark as invalid? And addressing this question is critical since there could be multiple such reasons and then for each reason, we might apply different mitigation techniques. When we address this question, we find that there are multiple reasons, and one of them actually is the main one is the reports considered as out of the scope of the programs. And again, this is also raise another research question, that what is the characteristic of the out of the scope reports? Because if we can find some kind of like a common characteristic for out of scope reports, we might be able to create some automation mitigation techniques to address these type of reports. Our methodology to address these questions, we conducted an empirical study on all public reports in HackerOne. We analyzed all public reports with the status of not applicable and informative, and we identified around 1,028 reports that was marked as invalid. We look at the conversation between the security professionals and the reviewers to find the reasons that render this report as invalid. And these are the 5 main reasons that we identify out of analyzing all of these 1,228 reports. The main reasons was one of them was out of scope, false positive, no proof of concept provided, fixed internally, and copy and paste. From these reports, we can see that out of scope and false positive are the main reason that mark this report as invalid. Out of scope are referred to reports that they could be valid, the content is valid, is a valid report, but however, it's not in the scope of the programs. And then false positive is mainly referring to the reports that really technically is not valid. It's just based on some kind of like a wrong assumption, and then it's not possibly, we cannot exploit the system or software using that report. Then we reach to second question, what is then the characteristics of the out of scope reports? For doing that, we look at the all policy pages, since the primary source of truth that defines the out of scope criteria for each program is the policy pages. We study and analyze each policy page of all programs in HackerOne, including 240 programs and background around 80 programs. We extracted a set of attributes that describe out of scope criteria. We tag each individual policy pages, and then we clean the output. We merge duplicated attributes, but based on that, we created our taxonomy model. So our taxonomy model consists of 6 categories: attack surface, vulnerability type, disclosure, configuration, SecPro environment, SecPro activities, and ad hoc criteria. And then each category consists of some concrete attributes that describe what exactly is inside that category. From our out-of-scope taxonomy, we found that actually majority of the program are really concerned about the type of vulnerability. For example, around 73% of all programs, they are concerned about security professionals submitting a denial of service. I mean, doing a denial of service proof of concept on them and then maybe submitting a report related to denial of service, or maybe they do a social engineering on their users. So these are the top 9 out of interest vulnerability types that most programs, they don't like security professional to try to identify. The reason why these are selected could be also research questions, but this is just based on the reviewing the policy pages. We then use our out-of-scope taxonomy to further analyze all the out-of-scope reports and then find what is the reason based on that these report was marked as invalid, as out-of-scope invalid. And we observe that all of the out-of-scope reports can be tagged with our attributes of the models. And then we found that the vulnerability type is the main factor to determine if the report should be considered as in or out of the scope of the program. So basically, by analyzing all these out of the scope reports based on our taxonomy, we found that these are the main reasons that, for example, marking this report as invalid. Future work is that we hope this publication could make it a bit easier for us to collaborate with the bug bounty platforms, with program owners, reviewers, to conduct more qualitative research, because really they are the main owner of the stakeholders. They have lots of domain knowledge, and unfortunately, because lots of this information is private, we have not access to it. And then another work is that if we have, we could develop some kind of like a mitigation technique, especially for out of the scope invalid reports, based on the vulnerability type. Example of this system would be, for example, it could be a machine learning ML model system that could look at the reports that is submitted by security professionals. Then based on the policy pages, either programs, they explicitly define list of the vulnerabilities that they are not interested, so they consider that as out of scope, or maybe they could be an automated technique that can extract it from the policy pages. And then maybe we can have a kind of like a system, develop a system that based on that can look at the report, and then based on the defined type of vulnerabilities, it can find which one is, whether this report is related to any of these types or not. And then how we can use these systems, it could be used for a kind of like a vulnerability report assistant. So for example, at the time that a security professional is submitting a report, it could inform whether this report is out of scope or not. And if they can also find the type of vulnerability, the system can also assist maybe in terms of like the quality of the report, what type of information need to be provided. It could help the program owners at the time of reviewing this report to inform reviewer about the submission of out of scope report. They can also assist them reviewers to find the type of and the severity of the vulnerability. And it could also early inform program owners and reviewers about the criticality of the high severity reports based on the vulnerability type. So that's it. And sorry again for the delay.
No problem.
Happy to have. Yeah.
Thank you for your talk, and also for you, thank you for staying up late to present this paper at the ESEM. Let me check the chat. I don't see any questions, but I have one. It's mostly a curiosity about, do you think that your taxonomy as it is actionable enough to, for example, prepare coaching programs that the hacker one can give to bounty hunters, ethical hackers, pen testers, whatever?
David, good question. I mean, it could, like, we could even develop a kind of like a system that based on that, it could create a policy page for new programs. Because when we actually reviewing the policy pages, we found that the quality of the policy pages also is not consistent. Some policy pages, they have a very well-defined policy page with lots of information. Some policy pages, they don't have that much of like a proper information. So this system also could help them to, when they creating their policy pages, they could inform them about the type of things that they can include, and then it can automatically maybe create some example of the sentence related to these types. But your question mainly is about the security professionals, if I understand.
Actually, from the platform perspective.
Yeah. It could be helpful for it as a guideline, as a general guideline that we can explain that how do you can create a proof of concept, like because creating a well-defined policy as a kind of like because this is a crowdsourcing platform, and one of the criteria of having a high quality is to define the task description in a very proper way. And this model could help them because it's based on the reviewing all policy pages and then look at how they define their policy pages. But again, really, this work is based just by looking the existing data. We really hope that this publication could help us to collaborate a bit more with these platforms. And then, as I said, because a lot of these data they have is private, and then I think really have a very good qualitative research with them could really have more insight in this domain. So,
but that's very good work. I mean, also again, interesting data source to analyze, definitely.
Yeah, thank you.
Thank you so much, Saman.
Thank you, and sorry for the technical issue.
Again, no problem. This concludes this first session on security and testing. We will be back at 15:30 Italian time for the second session. Thank you, everybody. I'll see you soon.